In the previous video, we introduced you to the one-way repeated measures ANOVA, and we introduced some of the concepts involved. Now we're going to go to an SPSS example.
Our example consists of measuring subjects across 4 weeks. We're going to measure them on the same dependent variable. In our case, the independent variable is weeks of pedometer wearing. The dependent variable is recorded steps. There are 30 people. We measure each of those 30 people across all 4 weeks. So it's a repeated measures or within groups design. We'll first show you the SPSS output, and then we'll illustrate with SPSS how we obtain this output. Here's the output. First we have the descriptive statistics across the 4 weeks. And if you look at the mean values, they tend to increase across those 4 weeks from a low of 44,000 to a high of about 54,000. At the bottom figure, we have
the test for sphericity. SPSS tests to see if you've met the sphericity assumption. And if you look at the red box, we have not, because it assumes, the null hypothesis for the sphericity assumption is that you have met it. And we have a significant difference if you look under the SIG column, so we have not met the sphericity assumption.
Therefore, you probably should consider adjustments to the degrees of freedom. Those adjustments are based upon the epsilon values on the right. We previously said there were 3 adjustments that could be made. We have the Geiser-Greenhouse, Tehune-Felt, and lower bound estimates. Notice in our case they're pretty similar, but essentially this is the value that you use to multiply the degrees of freedom in the numerator and the denominator in order to reference the appropriate critical value with adjusted degrees of freedom depending upon how much you have violated the sphericity assumption.
Notice that the lower bound epsilon is 0.333, which is the smallest of those numbers. When multiplied by the degrees of freedom, it is going to reduce the degrees of freedom the most. Hunt-Felt the least, and Greenhouse-Geiser somewhere in the middle.
Here is the SPSS output for the tests of within subjects effects. Importantly, we're interested in the weeks test, so that would be the numerator in the F test, and then we also have the errors or the within cell variance, that's the denominator in the F test. Interestingly, we have 4 different rows. We have results when sphericity is assumed, the Geiser-Greenhouse adjustment, the Tehune-Felt adjustment, and the lower bound adjustment. Now remember, in our case, sphericity cannot be assumed because we violated the sphericity assumption. Notice here we have degrees of freedom associated with each one of those. Importantly, the degrees of freedom when sphericity is met are 3 and 87. They are adjusted with each of the Geiser-Greenhouse, Tehune-Felt, and lower bound adjustments by multiplying the appropriate epsilon value. Recall that the epsilon value for the lower bound estimate was 0.33. If you multiply the 3 degrees of freedom when sphericity is assumed by 0.33, you'll notice that you get 1 degree of freedom now in the test when you have the lower bound estimate. If you multiply 87 times 0.333, you'll get 29 degrees of freedom. So notice how the lower bound estimate has the least degrees of freedom for making the test.
Notice that the F ratios are all the same. The F ratio is 10.335 in all cases. It doesn't change, but notice that the significance levels do change because you're going into the F table with different degrees of freedom to determine the probability of the event.
Importantly, in our case, regardless of whether you used any of the 3 adjustments or you made an error and assumed that sphericity was met, you still rejected the null hypothesis. The null hypothesis here is that the number of steps taken per week were the same across all 4 weeks. Here are 2 other pieces of output that we can also obtain with the SPSS repeated measures ANOVA. The first part on the top is simply a plot that illustrates what's happened. Well, if you looked at this closely, you'd think, wow, these 4 means, think back to what they were in the previous slide, they tend to be low in the first week and then go up and pretty much level off for the next 3 weeks. So literally what SPSS provides for us is a test, that's represented in the bottom frame, of whether that change across those weeks is linear, no bends in the line, quadratic, 1 bend in the line, or cubic, 2 bends in the line. In our case, all three of those are significant. Look at the significance value on the right. Importantly, if you looked at this figure and then looked at the sums of squares associated with each one of these effects, linear, quadratic, and cubic, you'd probably describe it as quadratic. That is, values for steps per week tended to be low in the first week, but by the second week and thereafter, they pretty much leveled off. Let's now turn to SPSS and illustrate how we got these output.
Here's our data set for the one-way repeated measures ANOVA. It's important to notice how the data are input. There are 30 subjects, so each row is one subject, and each column is 1 week. So for each of the subjects, we enter the steps taken in week 1, week 2, week 3, and week 4 across the table.
So now, to conduct a repeated measures analysis of variance, we go to Analyze, down to the General Linear Model, Repeated Measures. It presents for us the name of the factor. We're going to change ours to weeks. How many weeks were there? There were 4 weeks. So we'll add that. So the repeated measures consist of a variable called weeks measured on 4 occasions. So we'll now define them. A window pops up for the repeated measures. We'll take the 4 measures of weeks, we'll insert them as the within subjects variables. Let's obtain that plot. So we'll click on Plots. We'll move weeks to the horizontal axis. We'll add that as a plot we'd like to see. You could choose multiple plots if you wanted to. In our case, you'd only have one plot because there's only one independent variable. Click on Continue, and we'll say OK. We get a variety of pieces of output. We will eliminate those in which we're not interested for the time being. Here you'll notice the test of sphericity. It's the one that we saw previously, and you'll notice that we are going to have to adjust based upon these epsilon values because we failed to meet the sphericity assumption. Here's the test of within subjects effects. That's the test of weeks because the within subjects effect is weeks. And that's the same values we saw before. Notice the F values are exactly the same for each of the adjustments. Recall that we could adjust the degrees of freedom. Notice we can see how the degrees of freedom were adjusted. Recall that the lower bound epsilon value was 0.333. So if we take the original degrees of freedom, that is 3 and 87, and multiply those by 0.333 for the lower bound estimate, 0.333 times 3 is 1 degree of freedom now in the numerator and 29 degrees of freedom now in the denominator. Here's the results for the within test subjects contrasts, or the linear, quadratic, cubic tests, which we discussed in the previous slide. And here's the plot again that illustrates the fact that as you go across the weeks, there's a great increase in the number of steps in the first to second weeks, and then it pretty much levels off, but a slight increase thereafter. So now you know how to run SPSS repeated measures. The designs can become very involved if you have multiple repeated measures effects, or if you have some that are between and some that are within. But this is essentially the basic repeated measures design.